Tonight what we're going to be talking about is the structure of lipids. A couple nights ago you had some information, we started with some information about lipids in general as one of our 4 macromolecules that we talk about in living things. And now we're going to learn a little bit more about lipids. And to do that we're going to look at their structure. And so the objective that we have for this evening is to learn the structure of lipids. And specifically we're going to focus on triglycerides, phospholipids, and cholesterol. So those 3 are going to be the 3 that we talk a little bit about their structure. And this involves a little bit of chemistry, so you're going to have to remember some of the elements that are involved in lipids. We're going to have carbon, we're going to have hydrogen, we're going to have oxygen. So those are the 3 we're going to be working with here tonight. So first thing we're going to look at here, let's erase our objective, and let's look at triglycerides. Triglycerides. Remember, triglycerides, okay, are a type of lipid, and it's normally the ones we consume or we eat. So many of the things we do consume are triglycerides. So we often eat this kind. So let's look at the word triglyceride. So here we have tri. And I ask you, what does that prefix mean, tri? And correctly, you all say 3, because you all think of tricycles. Okay, so tricycle, triglyceride. So let's think about why that is. Well, if you look at my picture here, let's look at the glycerol. Look, glycerol looks a lot like glyceride, very similar words. And how many carbons are in this this structure of glycerol? There's 1, 2, 3 carbons here. So with these 3 carbons here, we have the 3 that refers to the tri, so a triglyceride. The second part that makes up, because there's 2 parts that make up a triglyceride. One is the glycerol, and the second is a fatty acid chain. And in this case, there should be 3 fatty acid chains. They do not all fit on my drawing here, so that's why I don't have all 3, but there should be 3. Okay, so you have a fatty acid chain, and when you see that fatty acid chain, which is a hydrocarbon chain, made of carbon and hydrogen, okay, and that is connected to the glycerol through a carboxyl group. So we have this oxygen here that actually we need to have this carbon with a double bond to oxygen. That is our carboxyl group right here. Okay, so we have that carboxyl group, and that is what we call a carboxyl group that attaches the fatty acid chains. And in each of the 3, it would do exactly the same, resembling, as we talked about earlier, the letter E. So triglycerides look a lot like the letter E. So that is the structure of our triglyceride. Now we're going to move to our next type of lipid, and that is a phospholipid. We're going to be talking about phospholipids a lot in this class. They come up often. So, phospholipid. Now we look at the word phospholipid, and right away we have phospho. So what do you think we're going to be talking about? What element might we referring to when we say phospho? If you guessed phosphorus, you'd be correct. And in fact, we deal with what's called phosphate. Okay, so there will be a phosphate group on one side, and on the other side you're going to have fatty acid chains. So let's look at the structure for, a little bit. A phospholipid is a lipid that has a phosphorus or phosphate head. And then oftentimes we can draw them looking a little bit like this. Okay, here's the structure, because we're talking about the structure primarily. And here is the phosphate group. And that phosphate group is polar. Okay, and polar means that it will have an affinity with water. It will bind with water. And then on this side we have, so this is our phosphate group also. And on the other side, we have our fatty acid chains. That should sound familiar from the last triglyceride thing we were just talking about. So we have fatty acid chains. And the fatty acid chain, this is polar. The fatty acid chain is non-polar. Okay, so, and we'll talk a little bit more about polar and non-polar sides of things as we progress when we start talking about the use of these phospholipids. Now, what's the really important function of this? Here's the structure. Yes, you guessed it, all the membranes in all parts of your cell. So the phospholipids are the type of lipid that is used for cell membranes and all the membranes that you find in a cell. So they're very important. And so that is one of the things that we will be concentrating on. And they normally line up like this. My drawing's not beautiful, but you get the point. Where the tail, it goes tail to tail with the heads on opposite ends. And so there's two layers of them. And this would be your phospholipid membrane. And that's what we'll be talking about some. Especially once we get to cells. Because when we talk about cells, it's very important. This structure and the polar and the non-polar will all become very important to us. But for right now, I'll just kind of leave it there and move us to our third group. Now our third group is cholesterol. And you guys all have probably heard, oh, don't have high cholesterol, that will be bad for you. Okay? So what does that mean? Well, you have these types of chemicals that if they are floating around in your blood, they can actually start to block your movement of blood in your body, in your arteries. And if that happens, that's when we start talking about when people get a stroke. And that's why having levels of cholesterol, these little lipid chunks, can be a problem. So if you're thinking about what cholesterol is and how commonly you've probably heard it, or maybe your parents have talked about it, that's where you've heard it from. So cholesterol, unlike those chains that we've seen in both the triglyceride and in the phospholipids, cholesterol, the structure is in rings. I will draw that for you here in a second. So it has a ring structure that's very, very different than from either of the other two that we've talked about. We aren't going to be talking about any fatty acid chains. We were talking cholesterol. The second thing that you know about them, about cholesterol, and this is important, is function. And the function of cholesterol, it is a starter chemical for making steroids. So that's one of the key things. It also is a starter chemical for vitamin D. Vitamin D is a very important chemical for your body, or a nutrient that we use, and it's one that, especially those of us in the Northwest who may not get enough sun, sometimes have to take supplementary vitamin D in order to make up for the fact that we don't have enough vitamin D naturally, because it does rely on some sunlight for some of the synthesis of vitamin D. So we have cholesterol, the structure is in rings, and the function is it is a starter chemical. Now, it kind of is an interesting word. That's the other thing I just want to add in here because that's kind of fun. It's actually from ancient Greek, and the Greek comes from chol, meaning bile, and sterol, or steros, meaning solid. So solid bile. Isn't that attractive? Okay, so, but sometimes when you know where the words come from, they kind of stick in your head a little bit better. So sometimes I like to add that in. So what do you have when I say, oh, it's made of rings? That may not make any sense to you. You may be going, what? Oh, made of rings? What am I talking about? Well, remember we talked about earlier the elements that make up living things. And carbon is one of those structures that is the key to making up living things. Didn't draw a very good hexagon there. So And one of the nice things about carbon is it loves to bind with other carbon, it loves to bind with nitrogen, it loves to bind with oxygen. It's a good binder. And since it does that, when we start drawing rings, we're actually saying each one of these corners is a carbon. Chemists, when they draw this, they don't draw every single carbon in here. I'm putting this in to help you out. But what they do is they assume that when we see a ring, we're talking about a ring of carbon. So that is what we are looking at here. And so you end up with this really interesting structure of sets of rings. And I'm just doing a lovely job of drawing here. There's a pentagon in there, and then it kind of goes up, and there's kind of a little chain at the end there. Every single corner you see on here is a carbon. If there's a bend, it's a carbon. Okay, so this is a carbon, and that's a carbon, and this is a carbon, and that's a carbon. That means the carbon is attached to each other. So that is that structure of cholesterol, and you can see there's a hexagon here and a hexagon here, really bad hexagon here, and a pentagon here. But these are a set of rings, and that is, you can see it looks very different than what we've been talking about with the phospholipids and the chains and the triglyceride and the chains. There's no chains here. These are rings. So a little bit different structure, but this structure then is allowed to be the starting point for making steroids and for making vitamin D. So this is to give you a little bit of information on how you have these different structures of lipids, because structure and function oftentimes go together, and we're going to be seeing that throughout the class. We will be seeing, especially with phospholipids, and we'll see a little bit more with cholesterol as well. So this is your homework for tonight, and I hope you have a good evening. Thanks.